Welcome back to Driving Force Radio. My co-host today is Kelly De La Torre, and we're doing a fantastic show on Energy 101. And our guest today is Alan Forbes, the president and CEO of Independent Energy Partners. And Kelly, we've been talking about this new technology, these geothermal fuel cells, which can go into retired oil fields and things like that, and really extract some of that leftover oil that's sitting in the ground, and it really becomes something that we can address through energy security, as well as there's so many climate things that are great and emission things that are great about this technology, and it's just a fascinating conversation.
It is a fascinating conversation, and what it points out is that, and what it makes me think about actually is when they first were developing these oil fields, it's crazy to think that where we stand now with our technology to then, I mean, they were really brave, I'm thinking. And that's just what I was thinking during break. But before we went to break, we were talking about the regulatory issues and how they also impact the economic issues. Is there, I mean, we talked earlier about the economic benefit of using these fuel cells and that they make economic sense. Is there any reason why you would need to use incentives, or are there incentives available? We always talk about this on the show, as that these things are subsidized, and in order to get to market, because it's difficult to get these things out to market.
That's true. That's true. But because of the very high thermal efficiencies associated with this geothermal fuel cell process, which translates into strong economics, we don't need the kind of incentives that you hear about with, for example, wind energy production tax credits, energy production tax credits, and some similar benefits are available to solar power. We do, however, because we qualify under EPA guidelines as green energy, green tech, and under some oil and gas industry regulations that have similar incentives. Production tax credits, energy production credits, renewable energy credits. There's a whole basket of those things that are available to us that we'll utilize in the overall bottom line enhancements of our business that'll be most meaningful to investors and shareholders in our company. But from a basic project economic standpoint, we don't need them.
Well, and in light of the benefit that this would bring to the United States as far as our energy security and our ability to help control sort of our role in energy politics, global energy politics, by allowing us to select what countries we wanted to deal with and all of that, it seems important to get the consumer involved and knowledgeable about what's going on in the industry, because obviously the oil and gas industry hasn't always been viewed favorably by the consumer. And this is something that is really a benefit. It's a benefit to the environment. It's a benefit to our security. It's a benefit to our lifestyle, like we always talk about. So how do you envision that rolling out across the country? And if there are listeners that would like to get more involved, how would they get engaged in helping you get this technology out there?
Well, I think you had commented earlier about educational needs. I mean, in my opinion, I think just taking the opportunity for interviews such as this one to raise our visibility, have people understand that this 21st century technology has been developed, the variety of things that have occurred, most significantly in material sciences, that have allowed these the fuel cell industry and solid oxide fuel cells in particular to operate at the efficiencies and in the manner that they do. There's a lot of that stuff that's going on in the background, from places like NASA to Pacific Northwest National Labs, which is a very, very strong material science organization, and all the nanotechnology and carbon fiber things that are happening that people hear about in airplane wings and things that are lighter and stronger. This is a 21st century technology evolution, and I think for people to become supportive, they need to be more familiar with it. And so I think, in addition to like the ICOSA organization, certainly our website, we've got a blog, a lot of information and background, a lot of frequently asked questions, kinds of things that are available for people to review if they want to get a little more background on what we're doing.
Well, and Al, I have to ask the question because you talked about that the technology is in play right now, and Colorado School of Mines is going to partner with you in 2014, and then it really goes commercial in 2015. My question is really around our allied partners, especially in this hemisphere. We know, up in Canada, the oil sands and the tar sands, that's what we call them, the tar sands and the oil deposits that are north of us are massive in scale. Talk about the rollout on the commercial basis as you head into 2015, and what does that look like? Is it really focused here in the U.S. first and manufacture here, or is it really more of a global movement?
I think the answer to that question is both. Our initial beachhead business, the initial commercialization deployments, are programmed to happen here in Colorado. For a variety of reasons, our association with Colorado School of Mines, we have, as part of our business activities, acquired several billion barrels of mineral resources here in Colorado. But in addition to that, we have a number of parties in Canada, for starters, in the heavy oil tar sands arena, that are pretty excited with the prospect of using our geothermal fuel cell in one of the two big applications that are used to recover or produce tar sands right now.
I'll bet.
One is the one people see mostly in the news up in Fort McMurray,
yep,
with these huge open pit mines where they use these big clamshell drags and load up these huge trucks, and they process that oily sand, wind up with a generally what's referred to as a synthetic crude. Mm-hmm. And most of that, by the way, for your listening audience that isn't aware of it, about a million plus barrels a day comes in about 2 miles north of your studio at these refineries just north of I-70.
Sure.
Those are owned by Suncor,
right,
out of Calgary, and a big part of their production is actually piped down to the Denver area. It's refined. They make gasoline, diesel, jet fuels, and most of that motor fuels is still marketed under Phillips, I think. Mm-hmm. The other technique that's used up there, the acronym for it's referred to as SAGD, S-A-G-D, Steam Assisted Gravity Drainage. Huh. And it's not dissimilar to what I talked about earlier with steam injection in California. Basically the same process, where they burn natural gas in a boiler plant up on the surface. They inject that steam. The steam does two things. One, it warms up the formation. That thick tar oil becomes less viscous, and it flows, gravity drains, to a collection well, a horizontal collection well. It's then pumped to the surface and processed through the Suncor type facilities, and then on down to Denver. So that steam-assisted gravity drainage basically is using steam to add pressure. It's using the heat in steam to improve the viscosity that allows this steam-assisted gravity drainage production to produce tar sands oil. The application of the geothermal fuel cell in Canada, where we also received patent protection, is to use the geothermal fuel cell as an in-situ steam generator. There is a native moisture content in this tar sands. By dropping geothermal fuel cells into the formation, running them on natural gas, it'll actually produce steam in situ. That waste heat that we talked about earlier, mm-hmm, for oil shale production will improve the viscosity of the tar sands. And so you've got the same benefit of steam being produced on the surface for pressurizing the formation and warming it with the geothermal fuel cell. But the difference being is they burn natural gas to produce steam. We burn natural gas to run the GFC. We use the waste heat that was provided by the steam, but we're also producing massive amounts of electrical energy that would otherwise not be there. Mm-hmm. So we use fuel once and we get those multiple benefits. And so the economics favor
Sure.
the Canadian application. We have some similar interest in China. There's
my
actually
next question.
yeah, we've kind of been careful about China, just because of the intellectual property concerns, reverse engineering and the like. Recently, I was contacted by a large investment fund in Riyadh, Saudi Arabia, that own some big oil shale interests in Morocco, that would like to partner and use our geothermal fuel cell to produce that resource. So, and then I think one of the more interesting, and the answer gets a little more technical to be thorough with, but a really big and exciting opportunity is in Israel. Israel has a lot of oil shale. They are in serious need of more electrical energy. They're in serious need of more fresh water, and they've got a lot of natural gas. So with the oil shale to be produced, the ability to use the electrical output for a variety of things, including desalination to produce fresh water, and use their natural gas in conjunction with our geothermal fuel cell. That's a pretty interesting opportunity, and there's some really, really smart people in Israel that have put together some really interesting applications and development scenarios that in the not too distant future we'll have the time to pursue.
Yeah, what I like about this story too is that usually, or many times with as just sort of startup or emerging technology, you're out there saying, no, it solves this problem. Sounds like it's the opposite. Like, okay, when are you ready? When are you delivering our first GFC?
Yeah. So the demand, the interest level is definitely there.
Yeah.
And that again, that was why I'm pretty excited, and I know I've mentioned it a couple of times, not intending to plug Delphi Corporation, but they add a dimension to our commercialization capability that is pretty special.
So taking a look at the Rocky Mountain region, I mean, New Mexico, Colorado, Wyoming, such big oil and gas states, are the administrations in these states, the governors of these states, aware of this technology, and have you opened the door to conversation with them? It seems like they would be just as excited as Israel and Saudi Arabia.
I would say yes, although the discussions have been pretty preliminary up until just recently. But I can tell you, I did have the opportunity to speak at length with Gary Herbert, who's the governor of Utah, and he was absolutely...
Sorry, Utah.
What's that?
I left Utah out of my Rocky Mountain region.
Yeah. So he was absolutely kind of on the edge of his chair, excited with the opportunity to use this new technology to develop more of the hydrocarbon resources in Utah. So I think based on that more in-depth opportunity with Governor Herbert and some earlier opportunities in Washington, D.C., where I had a chance to speak with several different senators and other congressional leaders, I'm pretty confident about support.
Yeah. That's. What I was thinking more on the terms of educating. Once you have those administrations on board, then it's educating from the top down as far as your regulators go, and saying, this uses less water, less emissions, and my other question then is, there are other applications for this technology with the heating of the ground. Can you talk about some more future applications of the technology?
Yeah, one of them that was pretty interesting, and there's some folks really excited about it, and I guess I'll use Africa as the case study. There's a delegation that's been contacting me fairly frequently over the last couple of years with the interest in using the geothermal fuel cell to produce fresh water. And people don't realize this opportunity actually initially was presented to us from Canada. There are areas of Canada that are more or less arid, but are on top of existing large aquifers. But the groundwater is brackish, it's non-potable, so you couldn't produce it It's not even good for crops because it has a lot of heavy minerals in it that would leave deposits on the surface and certainly would not be consumable. The idea is to use the high operating temperature of the geothermal fuel cell in an aquifer environment that will actually flash that water from the aquifer to steam. It's brought to the surface, condenses, and you basically have fresh water being condensed from that steam out of the aquifer. And so there are areas of Africa that everybody recognizes are very arid, but also have those same aquifer opportunities in areas where there's a lot of natural gas, no water, and because of their remoteness, no infrastructure for electrical power, so the electrification of these rural areas, big initiative in most developing third worlds to figure out how to get this distributed, or some of them refer to it as village power, opportunities out in these remote locations where they can have electricity and have the benefit of that energy source. Well, this group from Africa is really keen on basically using the geothermal fuel cell in some of these remote arid locations to not only produce fresh water, but also locally the power output from the GFC would be that village power remote electrification that they need. So that's one application. Another one that's on our radar screen, and it's covered under our patents, is to use the geothermal fuel cell for hazmat remediation, hazardous materials. So as you have these Superfund sites and other areas that in the 30s, 40s, 50s had all kinds of nasty stuff buried, infectious wastes and viral and bacteria stuff from hospitals and the like. There are applications utilizing the high heat, which would neutralize those viral and bacteria kinds of problems in some of these landfill locations. So hazmat remediation is another application.
Interesting. I wouldn't have even thought of those. That's crazy.
Me either. And I know, is there applications with, I know from like, as you talk about the Superfund sites, with all of those other kind of sites that use trash or waste as methane fuels and things like that, is that an opportunity to look at as well?
It is. It is. And one of the two unique benefits of solid oxide fuel cells, aside from that high operating temperature, is that they are capable of operating on multiple fuels. So things like the methane that comes from landfill refuge recovery makes a perfect fuel for a geothermal fuel cell. So that becomes kind of a free fuel, with the output being a combination of, to some extent, hazmat remediation, but also the production of electricity.
Al, we've been talking about, we've mentioned Delphi several times about manufacturing and how you're going to step up manufacturing to meet this apparent huge demand that you have, which is very exciting. How do you envision that commercialization rolling out?
Well, we, from a corporate strategy standpoint, have purposely kept our organization small and pretty nimble with the working through partners, strategic partners, and investor groups. I think as we move into this 2015, 2016 timeframe, the size of this opportunity really lends itself to large organizations. On the manufacturing side, we've mentioned Delphi earlier, but on the deployment side, companies like Shell, Total, France's Total Petroleum. And so we have an existing agreement with Total, who is not only a technology but a funding partner as well. And our rollout strategy involves a significant portion of the likely ownership, but certainly the management and operating expertise coming from these large multinational organizations. It'll be interesting to see at the end of the day if it's a combination or it's exclusive with an organization like Total or Shell.
Right. Well, and as you've talked about this rollout strategy too, and you talked about it being primarily here in Colorado to really go forward because you've built these partnership agreements. I want to ask about the partnership agreements. You're a smallish, I'm not going to say small, but you're a smallish technology company in this energy sector. And it sounds like this partnership agreement kind of setup is really the way to go in this sector and in this field. Can you talk about the importance of Adelphi participating in Total and Shell and School of Mines and all of these folks in the success and the actual ramp up of the technologies?
Yeah, I think it sort of harkens back to several years ago when people trying to be competitive in a competitive economy, both locally and globally, talk about outsourcing. To me, because of the complexity of the oil and gas business and this opportunity in particular, the technology, the unbelievable expertise that the Department of Energy and Pacific Northwest National Labs in particular have brought, the idea of trying to develop, finance, manage an organization where you had all of that expertise in-house. I moved away from that business model 10, 15 years ago and have been pretty successful being a small company that looked a lot bigger because of those kinds of partnerships. And so I think, our business plan at Independent Energy Partners with respect to the geothermal fuel cell changed early on. We had actually planned on hiring the scientists and conducting the work that we ultimately hired the Department of Energy to do. Fortunately saw the error in our ways early on and took that path, and so as a result we have really A-team type players in all aspects of the work that we're doing, whether it's at the national lab, R&D level. Total is at the forefront, huge investments in the unconventional hydrocarbon space, a lot of it going on here in Colorado that a lot of folks aren't aware of. But
yeah.
There's large amounts of money, high levels of effort underway in addition to what Shell's doing, that's being sponsored by Total right here in Colorado, some in Wyoming and Utah as well.
Yeah, I like that part of the story is that it really highlights we do have amazing national laboratories with unbelievably smart people in them, and then the ability of DOE to help coordinate all of that and insert their expertise as well. I think it's so important now that to sort of expedite the path for these technologies to get out there. So I agree that these partnerships are definitely the way to go.
Absolutely, and to get them through.
Yeah.
It just seems like we've talked about the regulatory, we've talked about the environmental, and you just think about the regulatory entities and the environmental entities and the kind of horsepower and financial horsepower you would have to get through them as a small organization without a partnership with some of these very large, world-renowned organizations, as you spoke about with Total and Delphi and those folks, the labs. I mean, it would be very tough to do some of this stuff. So I think that speaks to the importance of building partnerships and working collaboratively instead of seeing it as a competitive way to work with each other.
Yeah, that's absolutely true. And with respect to the regulatory issues and all the attention that will take early on in permitting, and then generally just with regard to educating legislators and regulators, we have relationships with other local companies of world repute like CH2M Hill,
yeah,
who are very, very good at dealing with the local, state, and federal folks in the regulatory arena. So we'll be using those folks as well as part of another partnering arrangement as we move into those areas.
So Alan, we have a few minutes left. What can we expect from Independent Energy Partners in the short to intermediate term?
Well, I think the things that'll be in the news over the next 12 to 18 months are a series of milestones involved with the successful testing, both at Delphi and Colorado School of Mines, of the prototypes as we get ready to go to the field and actually make some oil. So I think over this next year to year and a half, we'll be moving, putting a lot of resources into that aspect of the program, and at the same time going back to probably PNNL, Pacific Northwest National Labs, to take a look at some of these other applications I mentioned, where there'll need to be some refinements to the solid oxide fuel cell components to the geothermic fuel cell for things like tar sands. Another big opportunity that we didn't touch on, but it's one of the other big ones for the United States, is in situ coal gasification. The coal to liquids arena, huge opportunity. We have several hundred years worth of coal deposits here in the United States, and on the one hand you've got EPA and a lot of folks trying to minimize the use of that coal in power plants, but there are technologies dramatically and favorably impacted with the geothermic fuel cell that will take that coal, gasify it, and then through a process, the technical term is Fischer-Tropsch, if you've heard that, is to take that gasified coal and actually convert it to high quality fuel, diesel, and gasoline.
Yeah. Well, Al, there's so much on the horizon. We're looking forward to hearing so much more about Independent Energy Partners. Thanks for being with us today.
You're welcome. Enjoyed it.
Have a wonderful weekend and join us next week.